Thanks everyone for being here tonight. My name is Rada Mihalcea. I'm a professor in the computer science department at the University of Michigan, where I'm also directing the AI lab. And together with the Arbor District Library, we started a few years ago this series, the Friday Night AI series, which really has the goal to engage more closely with the community on issues of mutual interest, like the one we'll be discussing tonight. And as we know, AI has been emerging in a number of different areas. We pretty much see it everywhere. And alongside with that, it's also the area of energy preservation and sustainability, where it does have positive implications, while at the same side, at the same time, also seeing how AI is really a consumer of energy. So in a way, there is both the positive impact, but also the potential negative impact. So what we'd like today to discuss is this relation between AI and energy, both in the way of how AI can help with sustainability and efforts in this direction, and also going the other way, how can we build, for instance, models that are smaller, that would consume less energy, or what are other strategies to minimize the energy consumption. So I'm joined today by two experts in this space, starting on the further right, Mosharaf Chowdhury. He's an associate professor in the computer science and engineering department, where he leads the SymbioticLab. His research focusing on making AI workloads more efficient, especially emphasizing the reduction of energy consumption through the ML Energy Initiative. He has several open source projects, including the Infiniswap, which is the first scalable memory disaggregation solution, FedScale, which is a planetary-scale AI platform, along with several others. And for his work and his lab work, he has received numerous honors and awards from various conferences in the field. Then closer to me, we have Alexandra Klass, who is the James Degnan Professor of Law at the University of MichiganLaw School, where she teaches and writes in the areas of energy law, environmental law, and natural resources law. In 2022 and 2023, she served in the Biden-Harris administration as Deputy General Counsel for Energy Efficiency and Clean Energy Demonstrations at the US Department of Energy. Her recent work has been published in some of the nation's leading law journals and addresses regulatory and permitting challenges for integrating more renewable energy into the nation's electric transmission grid, among many others. We are also joined by two PhD students who've been helping run this series. So we have Yara El-Tawil, who is a PhD student in the AI lab, working on computational models for emotion recognition and mental health. And also Snehal Prabhudesai, who's also a PhD student in the AI lab and the HCI lab, where she works on methods for uncertainty quantifications. So first we'll start with activity that will give you more of a flavor of the topic of discussion for today. This will be run by Yara and Snehal. And after that, we'll have a discussion for about 30 minutes. I will be asking our panelists several questions. So we'll address both sides of the relation of AI, between AI and energy. And then there will be time for you to ask questions. So just to give credit, like I said, this is a collaboration between the Michigan AI Lab, more broadly computer science and engineering department, also the law school and the Arbor District Library. So with that, Yara, if you wanted to join us, and Amanda. Sorry. Should we go down there? It's really up to you. If you want, you can go out there.
Hi, everyone. Oh, that was loud. Could we get the slides, please? Okay, so we're going to start today with just kind of a exercise to kind of get ourselves thinking about energy and AI and kind of how those topics relate and kind of what your opinions are. We want to hear from you. So if you could scan this QR code, we're going to go through a couple of poll questions. So we'll give you a couple seconds. So far we have 5, so I see more phones. I forgot to read the question, sorry. It is, in what ways can AI contribute to society? I see a couple of you still typing. So if you could wrap up in the next 10 seconds or so, that would be great. Cool, so I see just a couple things to call out: disease detection, automation, education, productivity, health. Yeah, lots of different things. Thank you for participating in this one. We're going to do the next one.
Okay, so the next question is, what are your greatest concerns surrounding AI tool development? Is it privacy and safety, spread of misinformation, environmental impacts, or loss of personal autonomy?
So it is the same QR code. You don't have to scan it again.
Okay, so it seems like the majority of you did respond. So the number one concern is spread of misinformation. And if you remember, we had a panel on this topic previously, as did we on privacy and safety. So those are the two key concerns. The next one is environmental impacts, which we would be talking about in this panel. And then there's also loss of personal autonomy. So thanks for answering.
Yes, we also had that one as a panel. If you are ever interested in looking at any of the panels, there's a YouTube channel for these, so check it out online. Cool, so this next one is, are you in favor of data center development in the United States to advance AI capabilities? Cool, so it looks like we've got 40 out of 47. If you're still wrapping up, no worries. And it's like a roughly even split, but it looks like a little bit more in favor than opposed. But maybe those last 5 votes are the tiebreaker. But I'm so sorry, we're gonna go to the next one.
Okay, so this is so tiny. Okay. The next question is, to what extent do you agree with the following statements? One is data center development is an inevitable part of our future, or I would be in favor of a data center developing near me if it raised my property value, or I would be in favor of a data center developing near me if its tax contributions improved local education and publicly funded services. Okay, so the scale is from strongly disagree all the way to strongly agree. And then the
Okay, so it looks like trending towards inevitable, but also not in favor of a data center developing if it raised your property value, and then kind of in the middle in favor of the contributions being improving local things. So very interesting. Thanks, guys. A couple more. Oh, there's another small one, so far away. To what extent do you agree with the following statements? I'm in favor of raising electricity rates for the purpose of adding more renewable energy to the grid. I would support AI and data center development if it increased the speed of decarbonization. The benefits that AI can bring to society outweigh its risks. And then we've got strongly disagree to agree. Okay, looks like we're slowing down. Less in favor of electricity rates, trending a little past the middle for increasing the speed of decarbonization, and a little bit in the middle for the benefits outweighing the risks, but below, so a little more disagree.
Okay, the next question is it possible for a data center to be a good neighbor to nearby home, land, and business owners? And so far, the trending one is no, but then things are balancing for yes and unsure. Okay, so now we have equal, no, and unsure, and then very few votes for yes. So yeah, this means majority people are unsure or say no for the possibility of data center to be a good neighbor.
Okay, and then last one, I think this one's a free response, but what would it look like for a data center to be a good neighbor? We want to hear from you. We've got some really good answers. I see a couple of you are still typing. For an AI lab t-shirt, does anyone want to raise their hand and tell me, elaborate a little bit on your response? Free shirt? Yeah.
I think I did some of those, like invest in the community, contribute to the tax base. Also, like, provide stable employment, which is difficult for data centers because they need people to build them, but not a lot of people to run them. So they generally operate like ghost towns anyway.
Thank you so much. And then we can do one more. I saw someone raise their hand.
Mine was more a question. I had heard that noise pollution could be a bit of an issue, if that's a concern.
Cool. Thank you so much for participating. We'll get to the questions at the end. And also, if you did participate, please see me after because I will give you a free t-shirt. And yeah, I think that was all the poll part of the activity. And I think we got some really good responses from everybody, so thank you so much for participating. Let me just double check that there's not more. Okay, yeah, that was it. Thank you, and we're gonna proceed with the panel. And yeah, thank you.
Right, welcome back, and thank you, Yara and Sneha. Thanks to everyone for participating. So just to get started with our conversation, to hear a little bit more about our panelists, I introduced their official background, but I would like to hear more about how you got started in your interest in AI and energy systems and sustainability. Whoever of you wants to start first.
I can go first. Thank you. So my research for the last 2 decades have been on building very large-scale distributed systems, systems like Apache Spark that data scientists use to analyze data, the planetary-scale AI system that Rada mentioned earlier, FedScale, that we built to do privacy-preserving machine learning. And as over the years we've been building more and more system, we have always thought about efficiency in terms of how can we use computing and memory and all those other traditional resources more effectively. Around 2020, we started thinking about what is sort of behind them. And then we started looking into energy. Like it seems that's the connecting factor. Everything that we do in computing needs to use some energy. And we started investigating how much energy does machine learning models consume. And back then, models were smaller, data sets were smaller, and nobody really cared when we said, okay, someone should look at it, and we started slowly investigating. Over the years, of course, the models become like very, very large, and we also sort of got ourselves together and started something that we call the ML Energy Initiative, which is our sort of approach to very precisely measure and understand the energy consumption of machine learning and AI models. But not just there, but going further and how to optimize and reduce their energy consumption. So that's where it got started. And more recently, over the course of working on this for 5-6 years, we have gotten to a point where our recent results show that we have built techniques that can reduce the energy consumption of large model training by 40 to 50% without any loss of accuracy or without slowing them down by just doing optimization of the whole AI stack. So that's where we are, and we feel like there is a lot more room where we can reduce AI's energy consumption.
Hi, everyone. So I know very little about AI, and I know very little about computers, probably less than most of the people in this room, certainly less than the people who are under 30 years old. But I do know a lot about the laws and policies that govern our energy system and our electricity system. And AI and data centers is putting a big stress on how we think about our electricity system, about what is the electric utility's duty to serve. We know what its duty to serve is for all of us as sort of regular customers, but data centers are really, really, really big customers, right? And they're also super innovative, and they also are sort of changing the way that we think about what we use electricity for, and how we're also going to allocate electricity. You know, we've never really had scarcity of electricity like we have with other resources like water in the West, for instance. And so a couple years ago, I decided to work with another law professor who's a water law expert, and think about other frameworks for electricity that are based on resources that have always been scarce, like water, and at certain times in the US in the past, natural gas, where we don't expect to have that resource available 24/7, 365 days a year, and do we need to make some changes to our electricity system, particularly for large loads like data centers, not necessarily for traditional loads like homes and offices and other businesses or even traditional manufacturing, and thinking about ways we can change, particularly our state laws around that, and potentially also federal laws in terms of flexibility, adaptability, efficiency, and all of the things that state legislators and state regulators can do that might be different than what they do right now. So that has kind of been my entree into the world of AI and data centers. It's really from the law and policy governing the provision of electricity.
Well, thank you, and it's great to have this complementary expertise. So I would like to start first with sort of the positive implications of AI on energy consumption, and we already started seeing some of these applications. For instance, AI can be used to forecast demand of energy, or maybe managing smart grids, or there is energy use in buildings and how to optimize that. So I would like to hear more from you about examples where AI can be used in a positive way for energy consumption, like maybe to reduce energy consumption.
So, I mean, you have already mentioned quite a few use cases. There are a few more, I think, that are also related to the AI data center themselves. For example, Google have shown they have used machine learning models to better optimize the cooling of their data centers that are actually, I don't know, the topic that we are discussing, and they have said that these new models can allow them to better manage the data center cooling and reduce, or rather, increase the efficiency of their cooling systems by up to 40%, which is significant. And I know some of my colleagues, they're working on building new materials for coolants, and they're using different kinds of AI models to search this massive search space faster than traditional means would have allowed them to. I mean, some of those ideas might take a while even to get into production, but there's a lot of use cases like this that are trying to optimize at the device level, at the material level, at the level of whole data centers, at the process level. So there's a lot of examples like that.
So Mosharaf was focusing in on how AI can help the efficiency of data centers themselves, but AI as well can help how we run the electric grid and the efficiency of the grid, both on the generation side and the transmission side, and then on the demand side, on the customer side. So, you know, if we want to move to an electric grid that is much more strongly powered by wind and solar and batteries, wind and solar are intermittent, right? They're not like a nuclear plant where you turn it on and it just runs 24/7. You know, you need wind, you need sun, and you need to balance the grid at all times. And so AI can be used to do much better forecasting over a broad area for when you're going to have enough wind, when you're going to have enough solar, how you're going to balance that. Also figuring out how many electrons can go through a transmission grid or a transmission line at any particular time. If you can forecast that better, then you don't need to build a lot of new power plants because you can use your system more efficiently. So AI can do a lot with regard to that. And then on the demand side as well, in terms of being able to, for households to use demand response, whether it's heating, air conditioning, integrating electric vehicle, batteries, virtual power plants, all the things that we really want to do and that like the city of Ann Arbor wants to do on a local level, AI can do all of that, make all of that work much better. So there's a lot of potential with AI to improve systems, particularly on the electricity side.
If I may add one more thing, what Alex just said that reminded me, there's a project that we are working with our ECE colleagues where we are thinking of how can we use not really using AI, but rather the AI workload itself has a lot of flexibility that can be used to convert data center from a grid burden to a grid asset, where it can absorb fluctuations from other sources that are consuming electricity, because data center computation, whether it's training or inference, they can tolerate some delay depending on sort of what kind of service they are providing, and we can use those to use data centers themselves to take more and take less and adjust whatever else is going on throughout the other parts of the grid.
Well, thank you. And it seems like there is really a wide scope, and perhaps we haven't even thought of all the possible implications. In terms of the grid, but also the data. Yes, if you have more thoughts.
I actually thought of a couple more things. One of the big problems right now in terms of integrating more wind and solar into the grid is what we call the interconnection queue. There are long lines for wind and solar to be able to be added to the grid. There's all these studies that need to be done. What are the upgrades that have to happen to the grid to allow that additional generation on? We have more clean energy projects waiting in the interconnection queue than we have power plants online in the entire country, and it takes years. So this is part of the reason why we're moving much more slowly in terms of a clean energy transition, and they're starting to experiment with AI to be able to do those studies much more quickly and get those power plants online. So, and they're also trying to use AI to expedite permitting for those projects as well. So coming up with different scenarios, being able to figure out what are the environmental impacts of different projects. So also on the permitting side of both building new projects and connecting them to the grid, there's a lot of AI applications there too.
Yeah, and that's very cool. So those will be also almost indirectly, even thinking what would be good policies, right? We can do simulations with AI for that. And I think Mosharaf, you also mentioned materials. So they are also, I don't know, almost on the side, but still directly impacting energy consumption. Now we mentioned applications primarily for AI helping with this energy use, but of course there are so many more applications. And all in all, as we know, there is this increased use of electricity, and of course we've been talking about data centers, which again will require a lot of electricity and water. Are there estimates of what is the environmental footprint of AI today? How quickly it's growing? What are some of the main drivers behind that?
Yes and no. Yes, in the sense that we have tools to measure them. No, in the sense that people who are training and serving all of these models that we use commercially, they actually have to use the tools, then get the numbers. What we can do is we can apply those tools on open weights model, like the models that have their weights available, so we can deploy them in the cloud, then we can run them, then you can use our tool to measure them, and we sort of have been doing that since 2023, just right after when ChatGPT, I think, was first released at the end of 2022, if I remember correctly. And what we've been doing is that for different kind of tasks, like chatting and code generation, image generation, video generation, image understanding. There are many, many open weight model. And by open weight, I mean the model has been trained by somebody else, but they made the model itself available so that anybody can download them and then run them on their GPUs. So we run them, then we measure their energy consumption, and you can actually see all of this information. We made everything publicly available, including the code that we actually use to measure. You can go to ml.energy/leaderboard. You can go there and you can see all of the frontier open weights model and how much energy they consume. In terms of factors that affect, some of the obvious ones are how big the models are, what type of computation needs to be done for the task the model is trying to do, what kind of hardware the model is running on, and some of the more non-obvious ones are how chatty the model is. Some models are very verbose and they talk more. Some talk less. The ones that talk more consume more energy because it creates more and more words, and every word needs more energy to be produced. So talking less, as many of us have heard when we're growing up, actually helps for AI models to be more energy efficient. The other thing that we have found, which is quite surprising, because when people think of AI and energy, they think of the models and the hardware, but we found that the software that we use to deploy and serve all of these models, there are way too many configuration parameters, and many of them can significantly affect how you deploy them, what kind of service level agreement, meaning how quickly they should be responding. Many of these factors also affect sort of the energy consumption of these models.
Alex, do you want to add anything?
So energy consumption of models, I don't know anything about, but there's lots of questions about what's going to be the electricity demand of all the data centers used to run all these models. And there's so much uncertainty there because you have all of the hyperscalers saying we got to build a huge data center here and here and here, and are putting in requests to lots of different utilities for their service territories, knowing that they won't build all of them, right? They know they need to build some of them. And so each of those utilities need to respond, whether it's consumers' energy, whether it's DTE, whether it's XL energy in a different state. And they do long-term planning and forecasting as to how much, how many new power plants they need to build or how much they need to buy on wholesale markets. And it takes a long time to build a power plant. So they need accurate forecasting of what their demand is going to be, but they need to build as if everything is going to happen, and then regulators need to decide what they're going to approve. And it's, back in about 2000, we thought we were going to have a huge increase in electricity, in part due to data centers and computing. We were doing a lot in 2000, and all the estimates were that electricity demand would go like this. You know what it did instead? Totally flat, because everything was actually much more efficient than they thought it would. We also had a decrease in manufacturing around that time, energy efficiency of all of our appliances. So if the utilities had built for this, that'd be really bad in terms of our costs and in terms of carbon emissions associated with fossil fuel-fired power plants. So people are really nervous right now about the uncertainty in demand. We are going to have an increase in demand. It's pretty clear that we are. How much? Is it going to be like this, or is it going to be like this? We don't know yet, but it's going to be a lot, and that's why some of these efficiency issues are so important right now, to try to keep it low and also to try to not make it move too quickly.
And that's actually a great segue to my next question. Like, what are ways to keep it low? So, I don't know, you've been hinting at smaller models. There are maybe other strategies, specialized promise, hardware, maybe, I don't know, smaller models in the sense more like experts, like more specialized. I don't know, what are different strategies to keep it low?
Well, one of the things that is really being debated now is how flexible we want either our laws or our regulations to require the data centers to be. So, the position of most of the hyperscalers is we need power 24/7, 365 days a year. We're not interested in demand response. We have no flexibility. But then when you dig down, all of a sudden, there is an opportunity for some flexibility. And there are opportunities for state legislatures to allow their utilities to maybe cut off data centers at times of high demand. We build the system for the sort of maximum peak load. And so most of the time, when it's not the middle of summer and everyone's running their air conditioning, we have lots of what they'll call excess headroom in the system. We have a lot of extra power available that we could draw on, but we tend to build for the peak load because nobody wants to not have power when they want to have power. So the question is, we talked about data centers being able to be more efficient, be more flexible. Can you require that through law and policy? So Texas passed a law last year that tells their electric utilities you can cut off data centers when you need to in times of high demand. Now, maybe that means the data center is going to build their own backup power. These are big companies that are able to, that right now are some of the biggest consumers of wind and solar energy. We can say that, hey, you can connect to the grid more quickly than you otherwise could if you ensure that all of the electricity powering your operations is from carbon-free energy sources, whether that's from nuclear, from wind, solar. You can buy it, you can build it. These are all things these are all sort of policies that states and public utility commissions, with the help of legislatures, can put on hyperscalers. And so there's ways to require and incentivize them to be more efficient, and these are the companies, of course, that are in a position to do that kind of innovation.
So building on top of that, it's not just the policies that can enforce all of these hyperscalers to become more efficient. I think it's also aligned with their goals anyway, because if you are energy efficient in your systems and runtime, then your electricity bill will be low. All of us understand that. It's the same thing for them, but theirs is like many orders of magnitude bigger electricity bill. And so they have incentives. So whether we have policy or not, they, I think, are continuously trying to make their workload, their systems more efficient. And in terms of how they're going about it, as I said, it's a full stack approach that goes down to the hardware level, where companies like Google and Meta, they are building specialized accelerators that they claim are more efficient than general purpose GPUs, even though GPUs are the more popular ones. And then at the software level, researchers like me and many of my colleagues, we are building these software tools that can identify what we call energy bloat, energy that are being consumed, but they do not necessarily do any useful work. That's why you can make things 50% or 40% more efficient without losing accuracy and slowing things down. At the algorithms level, there are techniques that are coming out that can approximate the same computation without doing as much computation as exact computation would need, which leads to also a significant amount of savings. And all this where we are not even exploring sort of multiple axes that, or degrees of freedom that we have. Because one thing is we want to save energy, but then the question is like, do we want everything done as quickly as possible? In many cases, we don't necessarily need to finish things immediately. Maybe it's fine when I wake up and then by 9 a.m. if it's done, it will still be fine because I'm not really looking at it. So we have flexibility in the time axis that can allow us to save more energy. We also have flexibility in the accuracy axis. Like there is, of course, a rush, especially in the ML community, where they are trying to beat each other in the benchmark by improving by 0.01%, and they're the leaders in the leaderboard. But from any realistic perspective, it may not even matter to users. Just to give a simple example, like when we are driving a car and we don't necessarily care whether it's 80.1 miles per hour or 79.9 miles per hour. We are roughly 10 miles over the speed limit, and we should think about before pressing the gas again. And many type of applications are like that. We just need a ballpark estimation, and as long as it's good enough, we are okay. So we can go further beyond just increasing efficiency without touching accuracy and time that we are already doing, but we can expose the trade-off for different kinds of applications where it's okay to slow things down, it's okay to prune and quantize and use local model that will be slightly worse but still as good for most tasks. So we have many, many choices that we can use.
And I think that's an excellent point. I was thinking, I mean, of course, Alex, you talked about policies and more like sort of from, I would say maybe top down and bottom up, but really in the middle of it, I think it's humans, right? And I feel guilty as a researcher. I mean, that competition myself, I mean, trying to have maybe models that are even more accurate, and the same we see, and usually the solution is you throw more compute at the problem and you get a better accuracy. And that's why, Mosharaf, I got so excited when I saw your tool. Now, if you report also, even like as a simple research paper, if you report not only accuracy, but also how much energy you consume, it creates more of an even ground for comparison. So it will be, I don't know, it's changing human behavior in a way. And I feel even at a large scale, and at some point, I don't know, it's OpenAI rushing to compete with Anthropic and all these others, and maybe building yet another data center, so they are even better. But if we could slow that down a bit, I think it's, and again, it's human behavior ultimately.
Yeah, I mean, what you suggested is, I think, it'll be an important first step, because all of the people we are talking about, OpenAI and Anthropic, these are researchers that you are training and I am training, and they are going on to become those researchers. And if they are trained, it will be slow, but they will always have that in the back of their head that, okay, what is the other dimension that is getting affected, and is it worth it? I think that will slowly change the behavior. It's unclear whether the business folks who are making all the decisions, how much they will listen to it, but I think there will be some pressure that we should be conscious of how much energy this little improvement is actually, consuming, and whether it's worth it.
So it's interesting to talk about this on sort of the human level and individual decision making, but then also looking at this systemic level. So, data centers and hyperscalers are very disruptive to the electricity system, and it is disrupting the utility system. And most people would think our electric utilities actually need a little disrupting, right? And so the question is it going to be a positive disruption or a negative disruption? Now, it's easy to think about what the negative disruptions are going to be, particularly in our current Trump administration, where there's a real focus on building more and investing more in fossil fuels and not in renewable energy. So one of the outcomes is utilities keep their coal plants open and delay coal plant retirement. They build a lot more gas, and they don't build wind and solar. So that would be, I would consider, a very negative disruption to the system. You could also have a positive disruption. So we have all of these wealthy, innovative companies that are in a position to build a huge amount of wind, solar, get the nuclear industry back on track. And so we could build a huge amount of clean energy, have many more big projects. That's going to bring the cost of all of that down, and that could really drive our clean energy transition. That could happen, but I do think that is where law and policy play a really, really big role, because unless that is either incentivized or encouraged or required in some way, not all companies are going to do that. Google has been really innovative about trying to do a mix of wind and solar and batteries and geothermal for its data centers. I would say not all of the companies are doing that, and it's going to be really interesting to see how those costs play out, how electric utilities react, and how regulators and legislators create systems for that, and sort of in what order.
So we are getting close to getting questions from the audience. Maybe just if you wanted to make like a final statement of what gives you hope, and then we can take questions from the audience.
I'm optimistic. I'm optimistic because we have seen similar things before, that there will be infinite demand, and then we built up a lot of capacity, and then those demand was not really useful. But because we have the built up capacity, it allowed people to be innovative and then build other things that we couldn't think about. I'm talking about the internet and the dot-com bubble and bust and all those things. We built up a lot of bandwidth all over the US, all over the world, which allowed us to end up with cloud computing, and before that smartphone, which also helped putting everything into the cloud, and we built up cloud computing, which allowed us to store all the data. We have all the data, which allowed us to add more compute now, which allowed us to have all of this AI model. And then even though at that point, I'm sure I was not around actively in research or anything, but people probably were worried, like all this build up, and then now we don't have anything to do with it. But because we had invested in the infrastructure, and I think in this case, as Alex was pointing out, all of these may lead to a lot more investment in improving the grid and other systems we have, but also coming up with new ways and techniques to build more efficient, more sustainable sources of energy, which may actually unlock doors to other technologies that we are not necessarily even thinking about. We are thinking in a way that AI is the end of it, but I feel like we historically have always underestimated humans, that we have always found more things and bigger things and more use cases. It doesn't make the old one obsolete, it's just that we build on top of these and do bigger things. And in general, the other reason to be optimistic is that there are tools, and more people are asking this type of questions, and more people want to measure. And as we ask, and as users become more conscious, companies eventually will also want to differentiate from others that, okay, we report better, we make everybody aware that this search, this query took this much, and with simple ways that people can understand. So these are sort of implicit pressure. They are not as strict as laws and regulations. But I think all of these things have an effect. This takes time, but eventually, I know we will move toward a better future.
I'm also optimistic in the long term. I do have some worries in the short term. I think it will take a while to move to the system that you sort of envision there, particularly on the electricity side. And I do worry that in the meantime, we build a lot of new gas plants. We build a lot of what I would consider sort of old types of infrastructure. And once you've invested in that, it's very hard to get rid of them. This is long-lasting infrastructure that's supposed to last for 50 or 60 or more years. And so I do worry about locking in more of a fossil fuel-driven system before we have that transition, rather than moving to that now. And I think that's where advocacy, legislation, policy, and innovation, and some brave companies that are willing to stick to their decarbonization and sustainability goals can really go a long way. So I think we have to be vigilant about that, but I do think the upside has a lot of promise as well, and so I'm optimistic for the long term.
Well, and that's great. So it's realistic optimism. So with that, we can take some questions. If you have a question, please raise your hand, and then we'll pass the microphone.
Thank you again. What is a question? Sorry, this is for anyone on the panel. What is something that you would like to talk about that you have never had the chance on the topics we covered today?
I don't know, we're both professors, so we kind of get to talk about what we want whenever we want.
Yeah, I mean, I was trying to think, like, I mean, typically in an interview, when someone asks that, then I say, okay, these are the things I didn't mention. Some of the things I sort of gave a gist of, like how we are measuring and how we're optimizing. But one thing I would add is that my long-term vision regarding energy is not just for AI, is energy of computing. Typically, when we teach computer science, people, we teach them, okay, complexity of an algorithm and how many seconds it takes to run the algorithm. And time, in some way, is easy because it flows straight. You can measure by looking at the wall clock, okay, some time has passed. Energy is much more difficult because you need sophisticated tooling to measure precisely how much energy something is consuming. So if anything, I would say my vision for the future would be anybody who is doing any computing, and at this point, everybody in the world is doing some computing one way or the other, especially with these AI models. You could just say in plain text, and it will figure out the program and run it for you. I want everybody to be able to understand if I say something take 13 joules. Is it high for that? Is it low for that? I also cannot tell that on the spot. But I want like future, all the students, whether they're computer scientists or not, to grow up with that sense so they can, like intuitively can say that, okay, this is too much for this, but this is not too much for that. And how can we distill and simplify and sort of install that type of knowledge base within all of us is, I think, something I would like to see in the longer term. So then none of this will be a problem because you could automatically see that, okay, sun is going up, now it's getting, and time is passing. Similarly, somehow we can tell that an energy is being consumed and we should be more careful. This is something my long-term research vision, like by 2040, everybody, all our students, at least in computer science, should be able to tell how much energy and is it high, is it low, is it too much, and what to do, like we do for time, which is very common. Any computer scientist you talk to, they'll be able to say complexity and so on.
I guess I'll say one thing, which this is something I actually say a lot, but I haven't said today, in that in order to sort of achieve this vision of a carbon-free future, which I think we can achieve, we have to build a lot. So there's often, opposition to this project, whether it's a, wind project somewhere, a solar project. People don't like change, but we can't move to a new energy system unless we build a lot of new infrastructure, transmission lines, wind farms, solar farms. That's a good thing because otherwise we're stuck with what we have now. And I do think that's a mindset that people don't have as much anymore. I mean, we used to build a lot of things in the US, whether it was trains or highways or new infrastructure. And I think there's a fear that change is always going to be for the bad. And I think we have to think about change can be for the good, but we have to decide what we want to build and then build it. Because otherwise we can't get rid of the things that are causing problems in our world today.
There is another question there.
Hello. So I wanted to have you comment on last October, Bill Gates came out with a statement that was interpreted by most, or a whole essay interpreted by most as being softening his stance on global warming. And then others also interpreted it as that he couldn't support AI and the global warming threat at the same time. So he chose to support the need for electricity for AI. So I guess I'd like you to comment on that if you believe what I said is an accurate interpretation of that.
So I don't know that I can speak to his motivations. Clearly, he is pulling back from his investments and his company's investments in some of the clean energy efforts that he has. I think he's still full speed ahead on a lot of nuclear projects, which of course are carbon-free as well. One of the things that I had heard, I don't know if this is true or not, is that when the Trump administration pulled back on a lot of the U.S.'s international public health efforts, that's obviously a huge priority for him. I think felt like he needed to put more money into that. So I'm not sure if he's I don't know that he's sort of against a clean energy transition, but he's not going to put as much money towards that. That is what I've heard, but other people might have better information.
Thanks for the great presentation. I have a question, because nowadays for the AI, we have so many technologies like the LoRa fine-tuning instead of full parameter fine-tuning, quantized LoRa fine-tuning, and also distilling the model from big to small. And I wonder, what do you see as the potential of those, low resource fine-tuning methodology as well as model distillation? And do you envision there's the upper bound for models capability? If we really want a capable model, we have to pursue, the data heavy and full parameter fine-tuning instead of this kind of LoRa fine-tuning stuff.
So to summarize, and perhaps my attempt to simplify the question would be the way we sort of use models, what happens often is that you have a base model trained on a lot of data. Then you have a specific task where you want to apply the model, and then you, what machine learning people would call, fine-tune the model for the specific scenario using data set that are related to that particular scenario. That is called fine-tuning. And then what the question was, we can do full fine-tuning where you change, like update all of the parameters of the model, or you could use other techniques where you update only a small fraction, and I'm oversimplifying, so machine learning people should forgive me. But essentially, you only update a small fraction of it, and you can get very similar performance as full fine-tuning. And this, I would say, is sort of the degree of freedom that I was mentioning before, that you can approximate sort of accurate computation with an approximate version of the computation where your results are very close, and in many cases, that's good enough. And those type of techniques can be used to reduce energy, reduce time, increase efficiency of the models. As for what are the limits, I feel like current way, the way we are building AI models and using them is quite empirical. There is no proof, there is no law that dictates how much we sort of can push. Before anybody says we have scaling law, it's not really a law, it's just an empirical observation that people have shown that as you throw more data, you need to, I don't know, increase the number of parameters to keep up with it. And then even there, people have said that, okay, maybe we should overtrain instead of increasing them proportionally. So it's mostly sort of people trying out in many different ways and seeing what works. And I don't really have any answer to that, like what is the limit. For example, one of the things at some point I thought about what would be an equivalent of scaling law for energy, that how much energy I need to spend for a model to get to a point to achieve certain level of abilities. And I don't really have any good answer. It's just a thought and still a thought, and we haven't, and also in being academics, we don't really have any resource, that level of resource where we can try out and test and see what that curve looks like how much energy we are spending and what the accuracy of the model looks like. The short answer to all of this is I don't know.
I'm looking at Eric in the back. Can we take one more question, or?
I'm curious about the incentives to entirely disconnect and have a private hyperscaler that just provides its own energy, operates as its own island. It seems like that wouldn't allow too much load shifting, and it wouldn't, and then you'd have two systems. The people are left with the old infrastructure, and the reliability goes to the hyperscaler.
So there's a lot of policy and on-the-ground experimentation with that. I mean, even now, like a lot of data centers have their own backup power. The problem is it's, diesel or gas. And I think most of them don't want to be relying on that exclusively, but if you have a system where they're connected to the grid, but then they have backup power, or the ability to get that, or do some sort of a virtual power plant, then you don't have to build to that peak anymore. So that's going to help in terms of the flexibility. Illinois is, the legislature is, I don't know if it'll pass or not, but there's been a bill introduced that says, hey, data centers, you can connect to the grid more quickly if you come and bring, there's this whole trend of bring your own power, right? But bring your own renewable power. So in Illinois, they've got really strict decarbonization policies, and they say if you bring your own carbon-free power, you can connect to the grid more quickly. And so those are the types of policies that I think can be good, because then when you have that, if you have enough backup power, you can contribute that to the grid. You're not going to be totally islanded, but you have sort of multiple reinforcing systems. And if they're carbon-free, if you overbuild, not such a big deal. So I think that shows a lot of promise, but you need to have you have to design the system properly. You have to make sure you're not going to overload the grid. And you need to make, and I think it's really important that you make sure that you're not adding a lot of fossil fuels to that. So I think we're going to see a lot of different permutations with that right now, both with nuclear plants and with new wind and solar, and then also some long-duration battery storage as well. That's a big piece of this as well. There's a new proposal that's, I think it's Google and XL Energy in Minnesota, where they're building a lot of solar. They're going to have some long-term battery storage and have this sort of backup system that can also help the grid as well. So more like that I would like to see.
Right, so I think we should probably close here. So I would like to thank the Ann Arbor District Library for hosting us. Of course, Mosharaf and Alex for participating on the panel and sharing their thoughts and expertise. Yara and Snehal for running the activity at the beginning. Also, Christina and Aura, whom you don't see here, but they've been helping organize this from behind the scenes. And of course, everyone for coming here tonight in this very windy evening. Hopefully it led to some wind energy somewhere. So with that, thank you.